Now we are in rectangular coordinate system. Definition. Ordered pair consists of two components written inside parentheses. So example, it's like 1 comma negative 2. So 1 here actually is your x, that's the first number, and the second number refers to your y. So what do you mean by x? X is the x coordinate in your rectangular coordinate system. So let's say you have that vertical axis, that's your y-axis, and the horizontal axis would be your x. And at the middle, you have the point of origin, that is the intersection between the x and the y-axis. And again, that's the point of origin. And what would be the ordered pair in the point of origin? That would be at 0, 0. Okay. In the rectangular coordinate system, it's divided into 4 parts. We call that quadrant. So we have quadrant 1. So this is counterclockwise. So that's the first quadrant. The second is here. Then the third. And then the fourth quadrant. Now, when you're looking at the x-axis, going to the right, it's the positive value. And then going to the left would be the negative value. And for the y-axis going up, it's the positive values for y. And going down, that would be the negative values for y. So if you're looking at ordered pair, for example, 1 comma negative 2, so this ordered pair has a positive sign, that's a +1, and then a negative. So if you're asked where's the location or what quadrant would be that ordered pair, so you're looking at positive for your x and then negative for your y, so that should be in quadrant 4. Okay, so we can label this quadrant 1 when your x is positive and your y is positive. On quadrant 2, your x here is negative, and then your y is positive. In quadrant 3, your ordered pair would be x is negative, and then y is also negative. In quadrant 4, that would be x is positive, and then y is negative. Okay, and that's our example ordered pair, and it's going to be in quadrant 4. That's the location. Okay, so by plotting the point 1 comma negative 2, we can do that by doing this. Say so our example a while ago, it's 1 comma negative 2, and then try to plot that point in the rectangular coordinate system. This is our y here, and we have our x here. So point of origin is at 0, 0. So you're moving 1 And then -2, it's a negative, so you have to go down 2 units. So 1, 2, so -1, -2. So from the point of origin, you're moving to the right 1 unit because it's a positive 1. And then you have to go down 2 units, and then you mark the point. And that would be the location of the ordered pair 1, -2, which is in quadrant 4. And then you can label that 1, -2. So that's how you actually plot the point. Next, we need to learn the distance formula. So just in case you're going to have another point, for example, something like this on first quadrant, and then you're asked what's the distance between the 2 points. So you can actually find the distance by applying the formula. So what would be the distance from the given point 1, -2 to the second point? So distance formula is the next one. Okay, so here's the distance formula that we have to memorize. Now take note that the subscript 2 is just a label, and subscript 1. So it means that that's point 1 and point 2. So it's like if you have point 1, -2, and then the second point would have probably 2, 3. So when you label this to apply the formula, you can actually say this is my x1 and this is my y1. So easier for you to plug this in to the formula. So this one is your x2 and y2. Now be careful, the numbers as a subscript here is just the label. So do not put that as a power, like x power of 2. So that's a wrong actually notation, and your answer would be different. And then finding the distance between these 2 points is just plugging in using our formula here. So you just go, it's a radical or square root of x2, our x2 is 2, minus our x1 is 1, and then power of 2 plus, and then y2, just look at y2 here. So y2 is here, that would be 3, and then minus our y1, which is -2. So do not forget that's a negative, so there is a minus sign from the formula, so take note on that one. And the given y1, it's a -2, so you still have to put that in and then you square. Okay, trying to calculate for the distance. So that's our d. And 2 minus 1, it's a 1. 1 times 1 is a 1. So you will get 1 for the first group. And then on the second group, it's 3 minus 2. So that would mean that would be 3 plus 2. So that should be 5. 5 times 5 is 25. And then you add 1 plus 25, it's 26. So your distance is just radical 26. 26 doesn't have an exact square root because 26 is not a perfect square. So perfect square would be 25. That's the nearest one. But 26, you can think about the factors of 26. Could be 2 and 13. 2 is not a perfect square and 13 also is not. So just leave it like that. And our answer now is just radical 26 to be exact. Okay. And that's how you apply the distance formula. Next would be the midpoint formula. So it says here the midpoint M of the line segment with endpoints P, x1, comma y1, and ordered pair Q, x2, comma y2 has the following coordinates. So you're just applying this formula x1 plus x2 all over 2. So that's the first x coordinate for the midpoint. And then the y coordinate would be y1 plus y2 over 2. So that's the formula. It's like the 2 here, it's like you're taking the middle part. It's like you're taking the average of the two items. So it's something that you can relate to the word midpoint. Midpoint means middle. So middle of the line. So if you have a line like there's a point here and another point here, and we connect this to a line, then the middle part would be the midpoint. So this is the midpoint. So easier for you to remember the formula. So you divide it by 2. Okay, so let's try an example. Let's say you're given with 2 comma negative 1, and then another ordered pair would be negative 3 comma 2. Now you can label the points again to easier for you, to make it easy for you to plug this into the formula. So we can label that as x1 here and y1. So that's 0.1. So it doesn't matter which one is your 0.1. It will give you the same result, the same with the distance a while ago. So just label it. But note that you cannot see x1, y2 because this is our first point. So if you designate this as your first point, you should have x1, y1. And the second one would be x2, y2. And you just plug that into the formula. So the midpoint, so midpoint here, we're just trying to plug that in. X1 would be 2 plus, so we use the parenthesis because this one is an ordered pair. And x2 would be negative 3. And then all over 2 because it's the midpoint, it's middle, and then comma. So that's for the x coordinate, and for the y coordinate, y1 would be negative 1 plus y2. Y2 is 2 all over 2, and then you close it with a parenthesis because it's an ordered pair. So the answer now is going to be 2 plus negative 3. So it gives you a negative 1. So the first x coordinate would be negative 1/2 or negative 1 over 2. And then the second one, it's negative 1 plus 2. So that's unlike sign. So you subtract, that should be 1 over 2. 1/2 positive because you have the bigger value, which is 2 there. should be positive. So that would be your answer. So this would be our midpoint. So basically, it's just applying the formula. So if you're thinking about um, using formulas, so that's actually what we're doing here. We're calculating distance and we're calculating the midpoint. Okay, so let's go for an example. Okay, I'll use my whiteboard here. And our next example, it's given actually a point P, and then you have negative 6 comma 12 for that point P, and then midpoint is given. So your midpoint is given, which is actually at 8 comma negative 2. Now, if I'm going to draw a diagram out of this, P is the endpoint. So of the line, so that would be assuming this it would be your P, and your midpoint is somewhere here. This is your M, which is the midpoint, and you're asked, for example, Q here. So the question is asking you find the coordinates for Q. So what would be the coordinates for Q? Okay, so what you're going to think about this problem is just algebra. You're just thinking about the same formula. So remember the formula, it's M, the midpoint, equals x1 plus x2 divided by 2, and then we have y1 plus y2 divided by 2, and it's an ordered pair. So if you're taking the first formula out, and it says the midpoint is at this coordinate 8, then you can just simply say 8 equals, and then you are trying to put the formula, which is x1 plus x2, right? So x1 plus x2 all over 2. So if I'm going to label our points here, this would be my x2, right? And this is my y2. And the missing coordinate for Q, that would be my x1 and my y1. So now I just have to plug in those values using the formula. So I will just say x1, my x1, I don't know what is my x1. So that's the missing item, plus my x2, I know what is x2, which is negative 6, then divided by 2. And you have 8 as given as the midpoint for the x coordinate. And then you just cross multiply. Cross multiplying is the key here. You can just put 1 at the bottom because it's a whole number, and the bottom is always 1. So by doing that, it gives you now, let's multiply 1 times x1 plus negative 6. So that should be x1 minus 6. And then 8 times 2 would be 16. If you have issue with cross multiplying, you can also multiply the whole equation by 2. So you can eliminate the 2 as a fraction, and you will get the same answer. So x1 here, solving for x1, we have to move -6 to the right, becomes 16 plus 6 becomes positive. And then our x1 now is equal to 22. So that's our first answer. X1 is 22. So 22 should be actually the x coordinate for Q. And then do the same thing with the y. So just do the calculation, -2 for the y coordinate. That's the midpoint. You're looking at this part here. So let's use red color. So -2 is there. So I use -2 there, and equal to y1 plus y2 over 2. So now I will actually plug in the value for y2 because y2 is given. So I have here my y2. y2 is there. It's given. It's in P, point P. So now I don't know what is y1. y1 is missing. That's our Q, the other endpoint. So y1 plus y2. y2 is 12 over 2. Then we have a -2 on the left side. And then you apply the same thing as we did in the first solution. You can actually cross multiply. So you can have the -2 and the bottom should be 1. Any whole number has a denominator of 1. And then you cross multiply, multiplying this first. And it gives you y1 plus 12 equals, multiplying the other one would be -4. And then solving for y1, that would mean -4 minus 12. So the positive 12 becomes a -12 when you move that to the other side. It's always like that. When you actually combine like terms, always take the opposite sign. So y1 therefore is equal to -16. And that would be our ordered pair. So you can finalize your answer by saying that your Q is equal to x1 is 22 and then -16. And that's what the problem is asking. Again, the problem is asking you find the coordinates of the other point Q of the segment with one endpoint P, which is given, and a midpoint that is given. So that's another problem in midpoint. You're just applying the formula. Okay. So memorize the formula. So easier for you to apply it. I'm going to mark the formula that I used from the midpoint formula goes here, and this one here goes here. Okay, and that's the answer. Now we learned how to plot points, so that's what we did a while ago. Now we're going to graph an equation in the rectangular coordinate system. So I'm going to show you the rules first. Okay, so let's change screen. So this is the rules in graphing an equation. So here we're just doing line graph. So we're trying to explain the basic graphing technique in plotting the line in the rectangular coordinate system. So I'll give you a chance to read the different steps. Graphing an equation by point plotting. So that's what we did a while ago. And then after doing the plotting of points, then that's the time you connect and you will form a line. So basically you're graphing the equation. So that's a line equation or a linear equation. Okay. So step one, find the intercepts. The intercepts actually can be found by setting the other variable equal to 0. So intercepts, it's the intersection between the x-axis and the line itself, right? Again, the intersection between the x or the y-axis and the line. So for example, I have a line example here like that. So here's my x-intercept here. And then solving for the x-intercept, we set y is equal to 0. And do the same thing for your y-intercept, just the other way around. Y-intercept is the intersection of the line and the y-axis. So here's my y-axis, and this is my x-axis here. So that's how you use the intercepts. Now, anyway, I will give you the formulas. So step 2, find as many additional ordered pairs as needed. So since we're doing lines, the minimum you can actually do is just 2 points. So the minimum, you can have 3 to make it sure that that is really a line. But you know, when you have a linear equation, you have a power of 1. So that's how you know that's a line. If you have a power of 2, there should be a curve now. It's a parabola. Power of 3, that should be a cubic curve. So still a curve. Step 3, plot the ordered pairs from steps 1 and 2. So you can have like an XY table and then actually assign a value for X and solve for Y. You can do that also. Step 4, join the points from step 3 with a smooth line, and then that would be now your graph. So it says or curve. So if you have a power of 2, so if you have a power of 1, that's a line. Okay. So let's switch our screen and try to give you an example here. So for example, you're given with an equation of a line y is equal to 2x plus 1. And then you can actually remember the equation before. So here's the equation. Y is equal to mx plus b. It's like a formula that we have to follow. So where b is the y-intercept. So this is where the line and the y-axis, it's intersecting each other. So at the intersection point, that would be the y-intercept. And m here is the slope. Now this is the rise over run. Okay. So again, let me write that out. Slope is represented with m, and that is equal to rise over run. It's like the inclination of the line, how inclined is the line is, or it's rise over run. So let's plot the points. So our first point actually is the y-intercept. That's the first step, looking for the intercepts. So you have y here, and then you have your x here. So 1, actually 1 is our b here, which is our y-intercept. So that would be 1, it's right here. This is our first point. Let's mark that one. It's the intersection of the line and the y-axis. That's the y-intercept. Okay. So it's a y-intercept. Then you need another point so you can make the line. So looking at the slope, your m. So your m here, it's 2. That's 2 over 1. So 2 here means the rise, and 1 is the run. Okay, so when you're going to plot this, you're looking at the first point as your base. Let me label the point of origin. This is the point of origin also. This is at 0, comma 0. And from the first point as a reference, that is the y-intercept, the red point here, you have to go up 2 units. So you have to go up 2 units because that's the rise. So 1, 2 here. So this is 1, 2, 3. Again, I have to go up 2 units from 1. So 1, 2, and then I have to move 1 because 1 is my run here from left to right 1 unit. So I have my 1 here, and then I will mark from that point. Okay, so let me repeat that. 2 is my rise. So from the first point, I move up 2 units because it's positive. If that's negative, you have to go down 2 units. So go up 2 units, 1, 2, and then you move to the right 1 unit and mark the point. And then now you have the line by connecting the 2 points. So you have this line now. And this is now by graphing. So this is the graph of the equation y is equal to 2x plus 1. So we plot 2 points and then we connect that. That would be the graph of the line. So now here's another way. Another way is using the XY table. So you can actually write XY table here. So, and then assign value for X and then solve for your Y. So that's another way to graph. So for example, I will assign X with 0. So I plug in X as a 0. So I will get Y is equal to 2 times 0 plus 1. Then I will get Y is equal to 1. So goes here. That's actually the y-intercept over here, right? So that's the first point. So the second point, you can actually assign like a value for probably x as 1. And then solving that, you can actually see y is equal to actually 2 times your x, which is 1, plus 1. And then now 2 times 1 is 2, plus 1 is 3. So that would be your y. So 3 would be your y. So 1, 3 actually is here. So exactly the same one. So if you're using this formula to graph, and you're going to find the y-intercept and the slope from the formula, then you can have the graph right away. If you're using the alternate solution, which is the xy table, you assign value for x and solve for y. And then you can actually create the same graph exactly.